Hello, everyone. Today we are going to be solving systems by the third and final method way, which is called elimination. So before we get going, if you guys could pause your video, and I would love it if you would try the ignite at the top of the page. All right, if you guys look at the top answer is up, you should have got a final answer of 8 comma -4 as your ordered pair. Now your first step, we zoom in a little bit. Obviously, your first step is choosing which equation is the best one to do the substituting. And remember, a substitution, you want to choose the equation that has a variable solved for, if that happens. This one, since it does, since x is alone on one side, that's the equation that we're going to substitute into the second equation. So your first step should have been you should have taken -2y and plugged it in for itself in the second equation. And once you do that, then it's just a matter of solving. -2y plus technically 1y gives you -1y. And then to finish solving for y, your last step should have been to divide by -1. And that's how you would have gotten your y variable. Now, once you know y, now it's simply just a matter of taking that, plugging that back into the other equation, and that's how you get your final answer. After taking -2 times -4, you get your final answer of 8. Now, the method today, elimination, is probably more similar to substitution than graphing. But the nice thing about elimination is that you don't, kind of like substitution, you don't necessarily need a graph for something like this. Now, elimination, there's going to be pros and cons, and I'll get into those in just a little bit. But first, I figured I'd write out, kind of like we did for substitution, the steps for solving a system by elimination. And I'm kind of going to do them hand in hand with example one. So obviously, it says, if we kind of read through some of our directions, it says the first step is to write the system so that like terms with the same number now and um, with the same number and opposite signs are aligned. Now, sometimes this opposite signs piece is something that you have to kind of work through, and we'll get there in just a moment. But what we mean is if we look at example one, we just really want to make sure that X and Y right now are kind of all aligned and in the same setup. So for example, my first one, we have X, we have X, we have Y, we have the equals, and then we have a number on the right side. I want to make sure that my second equation is kind of the same setup. We have X, then we have Y, then we have our equals, and then we have just a plain number on the other side. So in terms of setup, we are good to go so far. Now, the second part is something that hasn't really happened. It says the same number and opposite signs are aligned. Now, we're not quite there. Now, in a way, we are though, because if we look, what we mean is we're looking for something like this to happen. And you're kind of comparing the two equations. If I look at that x variable, they have the same number, they both have a 3 in front, and they have opposite signs. This is actually what we're looking for. I was looking at example 2, sorry guys. But example 1, that's actually what's happening. So you're going to see why that's important, because in our second step, it says add the equations together, eliminating one variable. And that's the nice thing about when you solve something by elimination. Basically, the process is to add the equations together. Now, it's not always going to be quite that easy because sometimes adding them together right away doesn't really help you. But elimination, the gist is going to be kind of what we're looking at here. If I add my like terms, so -3x plus 3x, those are going to cancel. If I do 4 plus -6, technically that's the same thing as 4 minus 6. That's going to give us a -2y. Bring down the equal sign. And 12 plus 18 is going to end up being 30. Now, elimination, this is where it gets its name. If you'll notice, those x terms, they completely eliminated. When I took -3 plus 3, they cancel. That's why we're looking for the same number, but opposite signs in elimination. Because once that happens, now if you look at what's left, solving for one of your variables is super easy. Just divide by what's in front of y, and you get your final answer for y. Now, just like substitution, we still have only really found half of it. That's why the third step is kind of the same. Now, for step two, I kind of skipped over this. I said it, I didn't actually write it though. It just means solve whatever's left. Now, once you get your variable for y or x or whatever the case, whatever happens in your particular problem, step three says substitute the value from step two into one of the equations. So just like substitution, this step isn't really different. Once you substitute it in, then we solve for the other variable and write your solution as an ordered pair. So once I now know what y is, now it's a matter of just choosing really your favorite equation. It doesn't matter. You can do the top one or the bottom one. I'm just going to do the bottom one just cuz. And I'm going to plug in whatever y is equal to. Since y is equal to -15, that's going to take y's place. And now we really just have to go through and simplify. I'm going to distribute that negative or multiply the -6 and -15 together. That's going to give me a positive 90. Woo, I forgot the x. Bring down the 3x, bring down the 90, bring down the equals, bring down the 18. And now we solve. Subtract the 90 to the other side. We're left with 3x is equal to -72. And then dividing by 3, running out of room. Let's move this guy down just a little bit. You're going to get your final answer of x equals -24. And that is your solution. Now, with elimination, obviously there are catches because sometimes, unlike example one, where these crossed out right away, that doesn't always happen. If we look at example two, if I try and add down right now, nothing cancels. So before you add down, that's where that negative, that same number but opposite signs is kind of what we're looking for. Now, if I look at my two equations, so far, one of those things is happening. I have the same number in front. Now here, if you look at your x variables or y variables, those two things aren't necessarily happening yet. Because if we look at those, neither of them have both the same number in front and the opposite sign. Now, we are pretty close though. If you look at your x terms in this example, in example two, here we have the same number in front, but the only thing that is missing is the fact that one of those doesn't have the opposite sign. Now, what's awesome about math is that there's a really easy way to turn one of those positive 4x's into a negative 4x. And that's always by using multiplication. So one of those equations, basically you want to multiply one of the equations by what it's missing. And the fun thing is that it doesn't matter which equation. What matters though is that you do it to everything. Because remember, if I'm going to take one of these terms and I want to multiply that 4x by -1, you can't, because it's in an equation, you have to make sure you keep the equation balanced. And to do that, that means you not only have to multiply the 4x by that, but also everything else in the equation that you multiply by. So if we kind of bring those equations down, the top equation we haven't messed with, that's just 4x plus 2y equals 28. Now my bottom equation is changing. Since I'm multiplying all those by -1, all of the signs that are in my second equation are all going to change. Now, when that happens, now we can go through and we can simplify. Because if I look at my x terms, we have the same numbers, but opposite signs. So now we can do the elimination step. I'm going to add my equations down. 4x plus -4x, those are going to eliminate. 2x plus 3x going to turn out to be 5x, or 5y, excuse me. 2y plus 3y ends up being 5y. And 28 minus 18 is going to end up being, 28 minus 18 is going to end up being 10. And when we divide by 5, you are going to get your answer for y. We now know as part of my equation that the y value is 2. Now, just like we were back in the other equation, once you find one of your variables, then it's just a matter of plugging it back into either equation that you would like. So I usually go back up to the top and choose one of the originals. So I don't know, let's do 4x minus my second equation, minus 3y equals 18. And we're going to start again by plugging in y for itself. And now we just simplify. I'm going to take negative 3 times 2. That's going to end up being negative 6. Then we're going to add that 6 to the other side. 18 plus 6 ends up being 24. And then we divide by 4 to get our final answer of 6, 2. Now, elimination, the great thing about elimination is that if they don't add down and cancel right away, that just means you have to multiply one or both of the equations. Now, just so you guys know, I'm going to kind of skip around. Originally, I had planned for this to be 2 days. So right now we're on the 5C day 1 page, not the next page, but the one after, the one where it says the 5C day 2 at the top. I'm now going to move to that page. So we're on the 5C day 2 page. We're obviously not going to do the Ignite. We're just going to start by doing example 1 on that page. Because there is one last type of elimination scenario that we haven't covered. And that's really just where if you look at either variable, X or Y, and nothing cancels. Kind of like the last one, but here it's not necessarily as easy as just changing a sign. If we look at my X's right now, they don't have the same number and they don't have the same sign. And actually, same thing with my Y's. Now, my Y's are a little bit closer. Here, those have the opposite signs that we want. One's a positive, one's a negative, but they are not the same number in front. So either way, in this example 1 on this page, and example 2, it's going to be the same problem. We're just going to practice eliminating each variable. So for this one, we're going to practice eliminating y. So if we focus on my 2 y terms, what's awesome is right now is that they already have the opposite signs. The tricky part here is we want to make them be the same number. Now, in elimination, the awesome thing is that means we have to do one major thing. If they're not the same number, that means we just have to multiply both equations by something. Now, if you can find a number that they both go into, then you want to multiply each of those by a number that would give you that specific one. But if you don't know what number both 3 and 5 go into off the top of your head, the easiest way about it is to multiply each equation by the other number. So my top one has the 3. I'm going to multiply it by the other equation, which has a 5. And vice versa for the second equation. Second equation has a 5. I'm going to multiply it by the first equation, which has a 3. And we can now go through and simplify. Now, just to make things easier, I'm going to rewrite these equations. So my top one, I'm going to now be careful. Remember, you want to multiply to not only the same side, but also what's on the other side of the equal sign. So if I multiply this whole top equation by 5, we're going to be left with 20x plus 15y equals 40. And then we're going to go through and I'm going to multiply my bottom equation. 3 times 3 is going to be my 9x. We're going to keep the 5 times 3, which is going to be negative 15. And 3 times 23 is going to end up being 69. Now, just double check before we do the elimination step. Just look at your y's right now. Right now, they have the same number, opposite signs. That means adding and going through the actual elimination is going to work. My x's, 20 plus 9 is going to end up being 29x. My y's are going to eliminate. And 40 plus 69 is going to end up being 109, which last step, solve for x, is going to be to divide both sides by 29. Now, that just doesn't actually turn out to be the nicest number. Fun fact, that is not a great number. Since it's a decimal, we're just going to leave it as a decimal right now. Now, I'm not going to make you go back and plug it into the equation, but right now, technically, this is where we're at. Oops. Technically, that's a decimal. I just don't want to turn it into a decimal, so I'm going to leave it as a fraction. And we could potentially go ahead and solve for y. Now, I want you guys to pause your video. I want you guys to try example 2. It's the same exact equation, but what I want you guys to do is I want you guys to try and eliminate x. So figure out what you're going to multiply both of these equations by in order to make your x's cancel. So I want you guys to give it a try. Pause your video now and see if you can figure it out. All right. If you want to check your answer, you should have got y to be negative 68 over 29. Again, this one, the y value doesn't turn out to be super nice, but the process, though, should have been to be something like this. Now, typically, remember this one, our goal was to eliminate those x's. So we always start by just usually multiplying each equation by the other coefficient. So you're at the top equation, you should have multiplied by 3, and the bottom of the equation, you would have multiplied by 4. Now, this one, there was a catch though, because if you just multiply by 3 and by 4, that doesn't make the signs be opposite. If you keep the top one as a positive 3, over here, your equation would turn out to be positive 12x plus 9y equals positive 24. And that's a problem because if you looked at your x's then they have the same sign and the same numbers. Remember, if something's going to cancel, you want the same number, that's true, but you want opposite signs. So a really easy way of kind of getting around that is whatever number over here you would like, make one of them a negative. So I chose to make my top equation a negative 3. Could you have made the bottom equation multiplied by negative 4? Of course you could have. It's kind of the nice freedom when it comes to solving something by elimination. But the key is that if they're going to end up being the same signs, like, and you can tell here too, if they're the same sign, that means one of the numbers you multiply by has to be a negative. So in this case, obviously we solve for y. Technically that becomes the y value up here. We did it the kind of the long way. Typically, we won't actually get kind of that crazy of an answer, but the method is what matters. Now, the last example I got for you guys, we're going to go, oops, sorry guys. We're going to be on example 3 on that 5C day 2. And it says here, we're going to use elimination obviously to solve the equations. Now, sometimes there is kind of a preliminary step. And that is if your equations don't exactly really look the same. Typically, whenever we're going to solve an equation like this, we want, and if you remember from the steps from the last day, the steps tell us in step number 1, write the system so that like terms with the same number and opposite signs are aligned. Now, before you can tackle the whole same sign, same number, you want to start off with making the equations kind of have the same setup. And usually what that means is we want the x term, the y term, the equals, and then any other plain numbers. You want your equations to be set up something kind of like this. So I want both my x and y terms on the left side, and I want the number on the right side. So for my first equation, nothing too crazy here. I really just want to add the y term over to this side. So that's going to become, woo, that x went crazy. I'm going to add the y term over. That's going to leave me with 2x plus y equals 23. And then my other equation has the y term on the left. I want to add my 3x over to that side. And once you do that, now your equations are ready to roll. Now it's just a matter of making your terms have the same number and opposite signs. And the great thing is you can really choose whichever variable you want. If you want to get rid of your x's, totally fine. I think just for fun, I'm going to work on getting rid of or eliminating my y's. And one of the main reasons why is because I only really have to multiply one of my equations. Because that y term has a coefficient of 1, there's a really nice number that I can multiply by to get 1 and turn it into the same number, a 2, but the opposite sign. All you have to multiply is by -2. So technically what you're doing is you're really multiplying by the opposite. You're really kind of doing the same thing. You're going to multiply my bottom equation by 1, top equation by 2, and then make one of those negative. Just so I don't have to redo 2 equations, I'm just going to do it all with the top equation. So multiplying everything by -2, that's going to give me a -4x minus 2y. And remember, don't forget the other side. -2 times 23 is going to end up being -46. And now we look at your y's. You have the same number, opposite signs. Now we can go through, we can add down, and we can solve. So what I want you guys to do right now, I want you to pause your video and I want you guys to find the final answer. Tell me what the solution is for this particular one. All right, so pause your video now and give it a shot. All right, final answer. You should have got your, well, forgot to rewrite it, but final answer should have been 9.5. And the reason why is because when you add down, obviously, -4x plus 3x ends up being a -1x. And remember, to completely solve, you want a 1 in front of that. So I'll just divide both sides by a -1, and that's how you get your x value of 9. Then once you want to look back to the original two equations, I just picked the bottom one. Really, you could choose either equation, but the gist is that you want to take whatever x is and plug it back in for itself. So once you do that and solve, 37 minus 27 is 10. Divide by 2, you get your final answer of y equals 5. Now for this one, I did say what is x minus 4y? And here, all I'm looking for you guys to do is use those two values. You got x to be 9 and y to be 5. All I'm looking for you to do is plug those in. Plug in x for 9, plug in y as 5, and tell me what that equals. 4 times 5 ends up being 20, and 9 minus 20 ends up being -11. All right. If you want a couple extra practice problems, you can try some of the You Try Nows on the next page. But if you are feeling good with everything, then you guys can now move on and start working on your homework.